In this video, we are going to discuss the solutions of CPET 2024 mathematics questions. First of all, we will start with the questions related to numerical methods. So let us start with question number 65, in which we have to find an approximate root of the equation x cube minus 2x minus 5 equal to 0 using secant iterative method with the given initial approximations x0 equal to 1 and x1 equal to 2. So here the function f of x is x to the power 3 minus 2x minus 5. The given initial approximations are x0 equal to 1 and x1 equal to 2. The secant iterative method is given by xk plus 1 equal to fk into xk minus 1 minus fk minus 1 into xk whole divided by fk minus 1 for k equal to 1, 2, 3 and so on, where fk is f of xk and fk minus 1 stands for f of xk minus 1. So as you can see in the question, we have to find the second iteration. That is, basically we have to find the approximation to the root after the second iteration of secant method, means we have to find x3. So let us start with the first iteration where k equal to 1. So k equal to 1 means k minus 1 equal to 0 and k plus 1 equal to 2. So if you put k equal to 1 in the secant iterative method, on the left hand side xk plus 1 becomes x2, and on the right hand side which we will have fk means here k equal to 1, so f1 into x0, because xk minus 1 was there, so that's why it is x0 minus f0 into xk and whole divided by fk minus 1, which is f1 minus f0. So now we have to calculate the value of f0 and f1, because x0 and x1 are known to us, it is already given, the values are already given. So we need to calculate the value of f0 and f1. So what is f0? F0 is nothing but f of x0. So f of x0 means here x0 is given 1. So f of 1, which is equal to, you know that we have f of x equal to x cube minus 2x minus 5. So f of 1 is 1 to the power 3 1 cube minus 2 into 1 minus 5. So which will be minus 6. In a similar way, we will calculate f1. f1 means f1 is nothing but f of x1. So here x1 is 2. So we will calculate the function value at 2. So which will be 2 to the power 3 minus 2 into 2 minus 5. So which ultimately will get minus 1. So after calculating the values of f0 and f1, we will use those values to find the value of x2. So x2, now you can see in place of f1 we have calculated the value, that is a minus 1. So minus 1 into x0, x0 is 1, minus f0, f0 is minus 6 into x1, x1 is 2, and whole divided by f1 minus f0. So f1 is minus 1 minus f0 is minus 6. So after simplification you will get 11 by 5. So x2 value is 2.2. Now since we have to perform another iteration, so we need the value of f2, means that is f of x2. So now we calculate the value of f2, means f of x2, which is f of 2.2. f of 2.2 means here 2.2 to the power 3 minus 2 into 2.2 minus 5. So we will get 1.248. Now let us perform the second iteration for k equal to 2. So if we use k equal to 2, then k minus 1 will be 1 and k plus 1 will be 3. So for k equal to 2, the second iterative method gives us x3 equal to f2 into x1 minus f1 into x2 whole divided by f2 minus f1. So we have all the values with us. So we'll just substitute those values. f2 is 1.248 into x1 value is 2, minus f1 we calculated in the last iteration, so which is minus 1 into x2 value is 2.2 and whole divided by f2 1.248 minus 1. So if we calculate this, finally we will obtain x3 equal to 2.089. So no given option is correct. In question number 66, an iterative scheme is given to us. We have to test whether it converges. The iterative scheme is given by xn plus 1 equal to 1 by 5 whole into 16 minus 12 by xn, and n equal to 0, 1, 2, 3 and so on. So for this type of questions, let us assume the sequence of iterates xn generated by the given iterative scheme converges to L. That means let the limit of the sequence of iterates xn, this is equal to L. Now we take the limit n tends to infinity on both sides to obtain. So you can see on the left hand the sequence of iterates xn converges to L. That means the limit of xn plus 1 is also L. So on the left hand side we have L, which is equal to on the right hand side 1 by 5 whole into 16 minus 12 upon L. Now if you simplify this equation, we will have a quadratic equation in L, which is 5L square minus 16L plus 12 equal to 0. If we solve this quadratic equation, we get L equal to 2 or L equal to 6 by 5. So here you can see the option A, which is correct. That means the sequence of iterates converts to 2. Here you can see we have another value of L, that is 6 by 5. However, the given iterative scheme does not converge to this value because it does not satisfy the convergence condition of the fixed point iteration method in any interval containing this point. In question number 67, we have to find the first iterative solution of a given system using Gauss-seidel method. The given system is x minus 2y equal to 1 and x plus 4y equal to 4. Here you can see the coefficient matrix of the given system is not strictly diagonally dominant, so the convergence is not guaranteed. However, here since we have to find the first iterative solution, so from equation 1, let us write the first variable x in terms of the second variable y. So we will have from equation 1 x equal to 1 plus 2y. So from the second equation, let us write the second variable y in terms of x. So we will get y equal to 4 minus x by 4. As you know that in Gauss-seidel method, we use the latest values of the variables to find the value of the next variable. Here the initial approximations to x and y are not given. So test all the options in this equation, that is y equal to 4 minus x by 4. So considering all the options, you can see for x equal to 1, from the last equation, that is y equal to 4 minus x by 4, we are getting 4 minus 1 by 4, which is 0.75. So option D is correct. In question number 68, a quadrature formula is given to us. We have to find the values of the constants alpha, beta, gamma, for which the formula is exact for a polynomial p of degree at most 2. So here you can see the polynomial must be of degree at most 2. So we can take p of x equal to 1, p of x equal to x, or p of x equal to x square. So let us start with p of x equal to 1. Now if you put p of x equal to 1 in this quadrature rule, on the left hand side we have integration of 1 with the limits minus 1 and 1. On the right hand side you can see we have alpha into p of minus 1 plus beta into p of 0 plus gamma into p of 1. So you can see here we have taken p of x equal to 1, so constant function. So p of minus 1 will be 1, p of 0 is also 1 here, and p of 1 is also 1. So on the right hand side we will have alpha into 1 plus beta into 1 plus gamma into 1. That means if you put p of x equal to 1 in the quadrature formula, we will have the equation that is alpha plus beta plus gamma, which is equal to 2. Next, we put the value p of x equal to x in the same quadrature formula. So on the left hand side we have integration of x with the limits minus 1 and 1, and on the right hand side you can see alpha into p of minus 1. So here p of x is x, so p of minus 1 is minus 1, p of 0 is 0, p of 1 is 1. So we get another equation, that is minus alpha plus gamma equal to, here you can see integration of x minus 1 to 1, so it will be 0. So on the right hand side we have minus alpha plus gamma, or gamma minus alpha. So that means here alpha equal to gamma. And lastly we put p of x equal to x square. So on the Left hand side we have integration of x square, and on the right hand side we have, you can see, alpha into p of minus 1. So if p of x is x square, so p of minus 1 is 1, p of 0 is 0 square means 0, and p of 1 is 1. So we will have alpha into 1 plus beta into 0 plus gamma into 1. So we have another equation, that is alpha plus alpha plus gamma equal to 2 by 3. So using the equation 2 and 3, we obtain the value of gamma, which is 1 by 3, and since gamma equal to alpha, so alpha is also 1 by 3. And next we used equation 1 to find the value of beta, which is 2 minus 2 by 3, which is 4 by 3. So option B is the correct option.